Welcome to this lecture, guys. So in this lecture we will understand domain, codomain and range of a function. So about domain and codomain we have already studied in the previous class, but there is also something called range of a function. Alright, and codomain and range are both associated with the elements of set B, but there is a slight difference and we need to understand it. Alright, so we know that when you have two sets A and B such that A has elements 1, 2 and 3 and B has elements 4, 5 and 6, then if we try to do a mapping between A and B, then A is 1, 2, 3, B is 4, 5, 6, then we can draw a function between A and B such that this is related to this to this and this to this. Alright, so in this case we learned that all the elements of set A are called as domain and all the elements of set B are called as codomain. Alright, makes sense. Similarly, we also learned that it doesn't matter whether all the elements of set B are paired or not. Alright, like for example, this was A, this was B, 1, 2, 3, 4, 5, 6. So let's say 1 was mapped to 4, 2 was mapped to 5 and 3 was also mapped to 5. So we can see that element 6 from set B was left unmapped, right? Still we will say that codomain of this particular function from A to B is 4, 5 and 6, and obviously this will be in curly brackets. Alright, so this is the domain even if B is not included. So guys, when somebody asks you the codomain of a function from set A to set B, then all the elements of set B, even if they are paired with any element of set A or not, it will still be part of codomain. Alright, but when somebody asks you the range of a function, then in range you only include those elements of set B which are paired to at least one element of set A. Alright, so range of this function will be 4, 5. You will not include 6 in the range. Alright, codomain will include all the elements of set B even if they are paired or not, but range will include only the paired elements of set B. Alright, and domain will always be all the elements of set A. Alright, 1, 2 and 3, because there never can be a case where any element of set A is left unpaired. Then it will not be a function only, right? We learned in the definition in the previous lecture. Alright, so that is the difference between codomain and range, and codomain and range are both associated with set B. Alright, where the function is defined from set A to set B. Makes sense, guys? And there is some other word also which is used in general. So the domain is also called as pre-image. The elements of set A are also called as pre-image, and elements of set B are also called as images or image. So you will say that element 4 is the image of element 1, element 5 is the image of element 2, or you can say that element 1 from set A is the pre-image of the element 4 from set B, and so on. Alright, so these two terms are also used very often. Alright, and image actually means range only. So if somebody asks you what is the image of this function, then you will say that it will have two elements, 4, 5. Alright guys, clear with the concept of codomain, domain, range, pre-image and image? Now we can do some questions just for our practice. Suppose we are given a set A which has elements in set B. Alright, so now if we draw a function from set A to set B, and let's say all the elements of set A are associated with just one element like this. Alright, this is still a function, right, because it satisfies all the properties of a function. Now if somebody asks you that what is a domain, then you will say that domain is A, B, C and D. Alright, and somebody asks you codomain, then that will be C and E. But if somebody asks you the range, then that will be just element C. Clear? Alright guys.